Hello, this is before I get started. The reason I'm starting it just a little bit early before 12:45. I want to make sure my microphone works. I got this little lapel microphone right here. It works fine with the video recording app on my phone, but I'm not sure if it's going to work with the YouTube Live app on my phone. So let me plug in this microphone, and I want to tell you in the comments if you can still hear me. Alright. Alright, so I've got the mic plugged in. Can you hear it right now? If you can hear it right now, please say so in the comments. If you can hear it right now, please say so in the comments. Okay, so you can hear the mic. So right now, I'm by my phone, the mic's over there. Can you still hear it now? Interesting. Wait. Hear it now? Huh. Okay, I guess the lapel mic isn't going to work as well for this. Alright, I'm just not going to use the lapel mic. It's too confusing for this. Alright, so let's get started over here. Should have some better sound quality. To get started, let's play the Tanner Tech song. See how well I can get this. Oh. I've got my frequency generator right here. Alright, got that done with. That's the Tanner Tech song. So let's get started. First off, I have a slightly messy desk over here. So let me clean off some of this stuff. Yeah, I know I started early. Sorry about that to everybody that's watching. But I haven't actually started building the Geiger counter yet. And so everything should be fine so far. Just got to clean up some remnants of another project that I'm working on right now. For those of you who watch EEV blog, one of my videos was on EEV blog, and I showed how to make this frequency counter, and it had this LCD driver chip, and there was an Arduino generating the clock pulses and stuff for it, but a lot of people were saying that was kind of a dumb way to do it, and so I decided to make a dual 555 timer way of making these signal pulses for it. So I was just in the middle of doing that. But now, let's get started to build a Geiger counter. So here's my schematic for a Geiger counter. It's pretty cool. I found this somewhere. I'll put the link in the description eventually. Then I've got this, and I actually made this Geiger counter a long time ago. It's pretty old. It doesn't work as well because it only has a piezo buzzer directly inserted to this Geiger tube. And I think I blew this Geiger tube by putting 400 volts across it and no plate resistor for this thing. So right now I'm going to use this as the power supply because this thing can output 400 volts when you put 7 volts in, and it's 400 volts regulated, and that is what this Geiger tube uses. So I just got this Geiger tube, and I have a feeling this one's going to work a lot better. So I got some stuff to measure with my Geiger counter once I get it working. And so if Eddie Van Horn is in the comments, you might want to show yourself, because Eddie Van Horn sent me some of these really cool things. So he sent me these little things called I think trinitite, and it's pretty much this glass, and it's the glass that was made from a nuclear blast. And here's some radioactive beads he also sent me. So yep, that's him. So in this video we're going to make a Geiger counter with this tube and a very good detector circuit. We're going to measure some of that stuff. I also have some more radioactive material. These are little things from smoke alarms, the americinium. We have also got some uranium ore right here. I got this from Utah. And then that's pretty much it. We've got all those things. And we'll try that out after we get the Geiger counter working. Let me just clean off my desk a little more. Luckily, I have a bunch of breadboards that we can use for this project. Luckily, I have a bunch of components to use. So, yep, this is my Geiger tube. This thing costs about $15 off eBay. I think it's going to be a lot better quality than this Geiger tube. I think I also blew this one. This is Soviet old stock, which is pretty cool. It was probably made 50 years ago, but it's still new. Before I start, let's have some fun real quick with laser. I have this for Christmas, and I about making a laser thing. Let's give just give it. Yeah. Gotta put the good Tanner Tech logo. There we go. There, I made the Tanner Tech logo out of a laser. Oh, the stream's bad? Dang it, that means my Wi-Fi is... Dang. So is my Wi-Fi... Is the stream bad right now? Just, Ah, dang it. Here, just a second. Let me check my internet speed. I'll be right back. Just a second. Okay. Hold up. We're gonna try to find something out. Okay, we're gonna see how bad my internet connection is. It looks really bad right now. Alright. The internet speed's really bad. Just hold up a second. Alright, how does everything seem now? I'm running off LTE right now. Alright. Okay, is someone in the comments? Alright. Right now it's just running off 4G, so we'll see how it goes now. Okay. Yeah, see, look at that. Look how slow the Wi-Fi speed is. 59 megabits per second. That sucks. Well, let's start building the Geiger counter while I'm on 4G. If I switch over again, I'll make sure to let you guys know. So we've got this power supply right here. I'll fire up my soldering iron. And we're going to try to disconnect this little piezo buzzer and this Geiger tube so we can get 400 volts from this thing. And we're going to try to wire up this Geiger tube in the form of this circuit right here. So that way I can run my Geiger tube and have it actually hear a pulse on a speaker. Now I've got tons of components. I've got plenty of components to make this. So let's take the schematic and cruise on over here to my parts wall and see what we can get. Let's see, so we're going to need some 1 meg resistors. We're going to need 2N4403. I've got all that series up here, the PNP and the NPN series of that. Alright. So we'll put that down. There we go. There's our transistors. We're going to need some resistors. Let's see what resistors are we going to need. Oh, awesome. Someone's watching from Poland. That is cool. So we've got our transistors. Now we need some capacitors. We need some resistors. We're going to need a lot of 10Ks, 4.7K. Cool. So here's some more resistors we're going to need for this Geiger counter build. Let's see. Okay, someone just asked if I got into MIT, and I have not gotten into MIT yet. I got deferred even though I applied early action. So who knows? Maybe I'll get in March 14th when they send out all the other things. Cool. So I've got some components we need. Now we're going to need a 200 ohm potentiometer, 4.7 K resistor. We're going to need all these values. So luckily, I've got a whole bunch of parts right next to my fire extinguisher right here. So let's see what we're going to need. We're going to need some resistors. Luckily, I've got these things all laid out. We're going to need a 200 ohm potentiometer. Luckily, I've got just the thing. 200 ohm potentiometer. Perfect. We're also going to need some 3.3 resistors, a 22K resistor. Got 32K resistor. That should do just fine. What else do I need? Take a look down there. We need 10 meg resistor and a 1 meg resistor. Wow. Yep, there's a baby Groot up there, I think. True. I've got some other stuff up there. I've got this cool thing. It's like a magnetic egg timer. Looks pretty cool. And I've got a Dalek baby Groot. And then a Tanner Tech thing. That's pretty cool. I may set that during some of my videos, just kind of like a watermark. Alright, anyway, let's get some more components. I've got my 33K resistor. We need a 3.3K resistor. That's what we need. Let's hope I have some inside there. There's my 4.7K. We've got a 3.9K. I'm not sure if I actually have a 3.3K resistor. I'm kind of running short on some of my components. We got a 3K resistor. That should do just fine. It looks to me like the way this is, it's just going to the base of the transistor, and so we should probably have a perfectly running circuit right there. Alright, so we got a lot of resistors. We almost may have all the resistors we need. In fact, we need some 1 megs. I think we got all these ones taken care of. We're gonna need a 1 meg and a 10 meg. Now, on the data sheet for this vacuum tube, the 10, it says this thing only needs like 5 meg resistor. Oh, radiation source. Someone asked what my radiation source is. I've got some interesting stuff. I got some trinitite from Eddie Van Horn. He's watching this right now. He sent this to me in the mail. I've also got some of these here glow-in-the-dark beads that have radioactive material inside them. I've got some americium from smoke detectors inside this Altoids tin. And I've got some yellow cake or uranium ore from Utah. So, yeah, got plenty of radiation sources. Now let's start building this thing. So we're going to start with taking apart this power supply so I can get my 400 volts DC that I need. So, rest in peace, this old Geiger counter. It never worked as well as it should have. Ow. Got burnt. Alright, that's a pain. Just a second. Alright, so for those of you guys who are watching right now, or just got on, I'm just currently taking out this old Geiger tube from an old Geiger counter that I made a while back. Okay, right now I'm running off 4G LTE, so right now I'm using data for you guys. I don't have unlimited data, so my Wi-Fi is not working as well for this live stream. Yep, you're right. It isn't a real soldering job if you don't burn yourself. True story. Alright, so now let's connect some wires to this power supply so I can get my 400 volts DC. Now for those of you who just got on, this power supply is my old Geiger counter, and it produces a 400 volt regulated power supply. Let's get some wires for this thing. We need wires. Wires are very important for any build. Let's see, what wires do I need? There's a good black wire. No, that's not going to work. We could try this cool twisty wire. Which wire do you guys think I should use to connect my power supply to the other thing? There's a whole bunch of wires in here. Any guys in the comments want to say which wires they think I should use? Alright, I'll use this old wire. I think it's from a computer. There goes my wires, they just fell on the floor. So this thing was like an LED indicator light for a computer or something. Not anymore. Let me get my wire clippers. Alright guys, so breaking news, my favorite wire clippers are gone. Wait, nope. I spoke too soon. They are right here. So, let's try this. Someone just said the flat ribbon cable. Well, too late now. These are my favorite wire clippers ever. So positive source is right here, next to this thing. This is the positive voltage. So I'll stick that in, solder it in place. Now, we got a sad story here. I've got a bunch of solder, but it's all big solder. So I'm running low. I've got this big thing of solder and this big thing of solder. But this solder is not good to use for soldering circuit boards. And so right now I'm down to this last bit of solder. I'm running out. Not a good thing, but gotta make do with what you got. Solder that in place. There we go. That is good. That's positive. Now let's see, where did ground go? I think the ground... Oh gosh, I don't remember. I think it connected right here. We'll find out in a second if it works or not. Someone said I missed all sorts of information. What's the information that I'm missing? Please enlighten me. Alright, so this is, let me just explain this power source real quick. This is the power source to my Geiger counter. And I'll also explain how Geiger tubes work, first of all. That's the most important thing. So, let me find a pencil. So we've got a Geiger tube right here. And then we got another one right here. And pretty much what a Geiger tube has inside it is, we got a Geiger tube. And inside a Geiger tube, there's two main components. So we've got this inner bit, and basically all this inner bit is a little long wire, and it's just a wire. And on the outside we have this metal casing, and they're both separated from each other. So we've got the middle inside and the big outside. Now the middle casing will be charged to a positive 400 volts DC, and the outside is going to be grounded. Now it's also better to ground it through like a 5.1 meg resistor. And that makes it work better. Now what happens is when you have a radiation source, like from this whole pile of radiation sources, what that's going to do is it's going to cause little particles, radiation particles, to go through here. And there's an inert gas inside here, such as neon. And so normally when there's no radiation, no current flows through here. But when a radiation particle hits this, it ionizes some of the gas inside this tube, and it causes a short burst of electric current to flow from the middle wire to the outside case and through a resistor to ground. And so that makes a voltage on this part go up a little bit. And so that's basically how a Geiger tube works. And what we're doing is we just have a 400 volt power supply that I made a while back for an old Geiger counter. And it's basically got a 555 timer inside it. And the 555 timer puts out a variable frequency, and that frequency drives a MOSFET, and the MOSFET switches through this, I think it's like a 110 to 6 volt transformer into the primary, and then the outside part goes into a voltage doubler made of 2 capacitors and 2 diodes, and that goes into 4 100 volt Zener diodes, and that regulates the voltage to the 400 volts needed to run a Geiger tube. So that's pretty much that. Let's cut this off and make sure this thing still works. It's been like a year since I made a video about how to make this thing. I hope it still works. I really hope so. Let me just tin these leads so that way they're easier to work with. It's always easier to, yeah, neon is inert. It is one of the only gases, well, there are actually a bunch of inert gases, but it basically cannot combine with another gas to form an element. I took high school chemistry. Alright, so let's make sure these things fit in a breadboard slot. That's important. And they don't. I hate when that happens. See if I can cut off a little bit. Interesting. Now they do. Congratulations. These things fit. Okay, so the difference between the glass and brown one is if you look closely inside, you can see that little metal thing surrounding it right there. That little metal thing is like in my picture, this outside casing. And the little wire goes inside. You can see how the little wire connects through this little plastic ring on top. This big one is, the metal casing is the whole outside. And the little wire is hidden inside. So I think this brown one is going to be a lot better for this project. Let's test out this thing. So let me get my multimeter out. I love my good Radio Shack multimeter. Let me disconnect my laser. The laser is not useful at the moment. Alright, so just quick thing. The Wi-Fi is probably back now, and I don't want to run on my horrible internet speed the whole time. Just a second. It's been a while since I used an Apple device. See if the internet speed's still working. Anyway, let's test out this Geiger counter. Let me connect it to my multimeter, make sure everything's connected correctly. I've got this whole pile of alligator clips. Alligator clips are super useful. We're going to connect positive to red and negative to black. That's how I set it up. Hopefully that'll work. It's always annoying having to move around these leads from the multimeter. Now this thing is high voltage, but it's not high current at all. And so even if you touch this 400 volts current, it's not going to hurt you. I mean, it may hurt a little bit, but it's not going to do any permanent damage. That's basically because as soon as you touch it, the voltage is going to drop a lot. Because it's a very high impedance electrical circuit. And it's only drawing like 10 milliamps or something. Oh gosh, this is a pain. Alright. Is that fine? We'll see. Alright guys. Now you always want to set your multimeter to voltage. If you set it to resistance, you're going to really screw it up. We'll fire up the variable power supply in the back. Set it down to about 7 volts. That's when it works the best. And we've got it connected to the power supply. Alright. Now, let's just fire it up. I got my negative to negative. Positive to positive. And what do you know? 387 volts. Let me turn up the input voltage a little more. Ah, it looks like we're not going anywhere. Looks like 388 volts is the max we're going to get with this multimeter. But that should still be fine to run the Geiger tube. So, it looks like this thing is still working just fine. It's a high voltage power supply. Now the cool thing about this is you can use it to run neon tubes. Let's get a neon tube, just give her a little test. See how well this works. Put some wires on this, connect it. There's a good chance I could shock myself right now, but it's not high voltage, so no high voltage, no problem. Yeah, there we go, look it. We're running the neon tube just fine. Cool. That means, let's watch the voltage drop when I connect the neon tube. Wow, it drops to 86 volts. See, that's how high impedance this thing is. Even with the neon tube connected, it drops to 80-something volts. Well, let's disconnect the power supply so we can get started on getting the Geiger tube ready for action. Gotta put away a bunch of stuff. Oh, sweet. So I just got my iPod running Now we can try another speed test. See if I can finally connect to the Wi-Fi without going off my 4G and streaming. 4G streaming is not a good thing to do. It's going to waste my data so bad. Nope, what? It's not going to work right now. Oh, no. Someone's saying that about skipping MIT and becoming a full-time YouTuber. That's not, no, I don't think so. Being a YouTuber doesn't make that much money. And if I can go to MIT and get an electrical engineering job, then I'm going to be able to make far more money than I could ever make on YouTube. Ha! Yeah, you're lucky you have unlimited data. Look at that. My Wi-Fi sucks, and so right now I'm on LTE. No unlimited data for me. So let's get this stream done quickly so I don't waste much data. Okay. Now it's time to build this circuit as fast as possible. So let's do a speed run of getting the circuit ready. So we've got a breadboard. It's just a half-made breadboard right there. Then we've got Geiger tube. We've got some transistors. Let's follow this thing. Now I've kind of forgotten what's the pin out of these transistors. Let's try these PNP 214403. I'm thinking it's emitter base collector, but I'm really not sure. It's a pretty good question. I love this thing right here. This is cool. This is emitter base collector. Let's write that down just so I can remember. If I can ever find my pencil. Alright, there we go. This thing is pretty cool. So all the PNP transistors are just emitter base collector. And so we got 1, 2, 3 pins right here. The NPN transistors, I'm pretty sure these are the same emitter base collector because they're in the same 2N440 series. So this one should be emitter base collector, but it's always better to check so we don't have black magic smoke. I love this transistor tester. This thing makes it so easy. Oh no, I never actually found the STL file for this thing. I guess it just went away. There we go. That's the pinout. Ooh, looky there. Looks like the speed test never worked. That's just great. So we're going to be burning up data for the next few minutes. Let's get this done. Hopefully I can make enough money on this live stream so I can buy an extra few gigs of data. I think so. Alright, so the important part to start with is the Geiger tube circuit. And so we've got the Geiger tube power supply right here. So we're going to start connecting this power supply up. It looks like we're going to be running a common ground with the Geiger tube and the Geiger counter. So we're just going to connect this to ground. Because if everything's running off a common ground, then the ground for this thing is going to be 400 volts too. So let's connect this power supply, which is 500 volts, up to this little pin right here. Let's hope nothing happens. Now we need to get a big resistor that's, let's see, about maybe a 5-something meg resistor. We've got a whole load of resistors up here. I love it when I can organize my resistor like this. So let's see. We got 4.8 megs. I'm thinking we're going to use one of these resistors for the plate voltage. Now we want to keep the same proportion right here, which is 10 to 1. So I'll probably use like a 470K on this, so that way we have the same 10 to 1 proportion. So I'll connect this to here, and this to a point right here. Now, when you're ever building a Geiger tube circuit, you know that these two are separate. Ha! I will go Medi Cigar on this thing. Electrobeam's so funny. Alright. So, we got the 5.1 meg resistor. Now this is 10 to 1, so 5 megs is 5 million ohms. And so, let's try 500,000 for this resistor. If we can find it. No, let's try 5.5 megs. Maybe that'll give us a better working thing. Now I need to find 500,000 ohm resistor. 500 Ks. Alright. If you guys see a 500,000 ohm label on here, make sure to tell me. We could do 680K. That should work still. Not the best, but Whatever. Betty Tech. Yeah. That'd be fun to do a collab with him one time. He's in Canada, though. Oh, gosh. It's really annoying putting back resistors. These things fall apart so much. Luckily, I got all these resistors for like $7 on eBay. These things are the cheapest thing ever. Put it back where it belongs. Now we need to connect this Geiger tube up here. Now we got some solder right here, but I really don't want to solder this because it looks like the solder right here is blocking the gas inside. And so if I take out this solder, I could vacate the tube, the tube, and then it's gonna screw everything up. So looks like it's time to get out the wire bin. All right, guys. So my Wi-Fi is still not working right now. Check this out. We're getting 0.26 megabits per second upload. That really sucks. That's like, oh, that's bad. That's worse. That's just about as good as dial-up. So right now I'm running off LTE. So if you guys want to, like, go click on my ads or something, so that way I can get extra ad revenue, so I can pay for extra gigs of data because of this live stream, that would be a really great thing for me. Yeah. Let's get some wires to wrap around this Geiger tube. The best kind of wires for this are good wires. Now we'll just use this speaker wire. Cut off some bits of it. This will be the Geiger tube power. There we go. Oh, Super Chat. No, I don't have Super Chat. But Super Chat would be nice because if I think I could probably enable Super Chat, but not for this live stream. Maybe for my next one. I'll enable Super Chat later. Alright, let's connect this Geiger tube up. So I'm going to strip this wire a lot, so that way I can have extra room to connect it to this thing. Actually, I may need to strip this wire a little more. A little more. Pull it apart. We're going to twist this wire together, so that way we can... Someone just said make a Patreon so you can donate to me and build my parts stock. Yeah, I'll eventually make a Patreon. I was thinking of making a Patreon once I hit 10,000 subscribers. Not nearly enough subscribers yet, I don't think. I don't know. Anyone have any ideas about how to better connect this Geiger tube without soldering it? I really don't want to solder this, it could break it. Interesting. It's not connecting very well, is it? Well, let's see if I can get some alligator clips, maybe make some good use out of those. I got some really big alligator clips. Oh yeah, that's easy. That is the best way to connect these things. There we go. Looks good to me. No, I don't have a Bitcoin account. I have a PayPal account though. Okay, let's run the speed test again and see how well my Wi-Fi is working. Alright, so let's cut off some of this wire over here. And connect it into the breadboard. So if we look at the schematic, we're going to have to connect this thing pretty good. Now what transistor is this? 44003. So let's connect this one thing to ground. Now let's see which one is ground. White one is positive. This one is ground. Oh joy. That's a pain to connect. Doesn't really fit, does it? Well, that's a great thing. Let's connect this to another wire and then connect it inside here. Same with this one, which goes to the 1 meg. Okay, let's get out the wire box. This is the big wire box. I mean, second big wire box, more like. We got a whole bunch of wires inside here. I will connect these to the Geiger tube wires. Hopefully we can get something happening here. I've used so many wires for my other projects that are still halfway done. I don't have nearly enough wires for this project. Okay, let's connect it here. This is positive, so yellow. Alright, let me see what time it is. 1:13. I'm gonna have to end this live stream at like 2 something. Maybe like 2:20 or something. I got something I gotta do. But for now, let's see if we can finish this Geiger tube. Oh, this is not good. Let's connect this here. That looks good to me. Make a video about NAND gates? Yeah, I'll make a video about those. I got a bunch of NAND gates inside my box over there. So now we can take a wire and connect it. Maybe a smaller wire than that. So many big wires. Connect the wire to here. This is the midpoint between the 2 resistors. And we got it right there. So if you look right here, we just finished this part of the electronic circuit. We got the 500 volt power supply, the 10 meg resistor, 1 meg resistor, ground, that thing. Oh no, we need that. 22 picofarads. Let me get on that. We need something from here. This is a box of my little capacitors. I got so many, it's hard to find. That's 3 picofarads. That's 220 picofarads. 2 picofarads. 10 picofarads. Gosh, where's 22? 150. 30. You know what? 30 picofarads should work just fine for this project. When will you finish this project? I'm not sure I'm going to finish this project. I may put this project in like a real Geiger counter thing. This is kind of just to build something. I don't know. There we go. I got the 22 picofarad capacitor. I actually just put a 30 picofarad inside there because I really didn't have a 22 picofarad capacitor. So now we need a 2N4403 transistor. We got one right here. Looks like we're going to have to connect pin 2 to the base. Let's expand this capacitor a little more. Scoot this wire over so we can utilize more space. Connect it inside here. Building a breadboard takes a long time. In fact, doing all kinds of electronics takes a long time. Alright, so I got the base going into... If you look at the schematic, I got the base of this going in there. Oh gosh, looks like I'm going to have a 22K resistor biasing the base to positive. Well, let's find that 22K resistor. Where is it? 30K? I don't have a 22K out right now. We're going to have to find one in here, which is not going to work. Oh gosh. We're short on resistors. Looks... Maybe I can find a 22K inside this box. Nope. I got a 15K and a 17.4K. No 22.4Ks though. Alright, let's hope I can get lucky and maybe find a 22K. Oh, there we go. Look what we got right there. 22K ohm resistor. That's what I'm talking about. Let's put that thing in. Base. Oh, wow. There's a lot of bias resistors inside there. Whew. Connected there. Looks like pin 1 is going to be biased to the 3.3K. We're going to need a lot of 3.3Ks here. Let's see, 3.9K, that's about the best we're going to get. Maybe 3K. 3K, looks lucky there. We got 2 3K resistors left. That's perfect. Let me just verify these with my multimeter. Hey! Yep, I got like 20 breadboards too. Yep, this is a good resistor. So let's remember that 3.3K right there. So we're going to connect this bias resistor to the pin 1 of this transistor. What else goes to pin 1? What else goes to pin 1? A 0.1 UA microfarad capacitor. Oh, joy. Let's see if I can find a 0.1 microfarad. Got so many capacitors inside here. I've harvested these things from all kinds of places. 10 microfarads. Nope. 4.7. Nope. 10. Nope. 22. Gosh. Why are these small capacitors so big? 47. No, 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 no. 22. Nada, nada, nada. If I can find a 0.1, that'll be great. Ah, gosh. I'm going to give up on this thing. we're going to go look up here and find some capacitors that are ceramic. Maybe I'll find a big capacitor, 0.1 microfarad there. That should be like a 105 or something, I think. Oh, here's 105, 250 volts. Let's hope this thing even fits on the breadboard. If I can find a 105 that's not a gigantic capacitor, that would be great. I'm not sure how lucky I'll get there. Now, all I see are 104s. Maybe I can find a 0.1 inside here. Oh, there we go. Check it out. I just got lucky. There's a 0.1 capacitor. 0.1 microfarad. Oh, gosh. Well, that brings up some interesting problems. Looks to me like I gotta get this capacitor way over here. That's a little bit difficult for me to do. Yep. Alright, let's get this in. Get the capacitor there to there. This is just the signal capacitor. So we got this bias resistor right there. We got the capacitor. Oh, it goes to ground. Well, that'd have been helpful to know. Alright, so whenever you guys are doing breadboard electronics, you always got to remember to keep your resistor leads. These things are super important in the long run. Like old resistor leads, they're so helpful because you can easily use them to connect different rails. You don't have to use so many other bits. I'm glad the chat's pretty good right now. I love it when the chat's good. So that way when I get too annoyed with this thing, I can just take a look at the chat. Oh, okay. Direct message on Twitter. Yeah, I have a Twitter, but I almost never go on it. I'm too busy for that. Doing everything. So we got the capacitor going to ground. Looks like that capacitor is just going to ground. That's about all for that bit right there. Now we got to get another 3.3K. Luckily, we got it right here. That goes from pin 3 to pin 2 of the next 4401 transistor. Oh, looky there. We got a bunch of things. Hey, look at that. Everything worked out perfect because I can put this transistor right here. And then we have the pin 3, which is the collector biased through this right here. And then we got, oh, we gotta get a 3.3K to pin 2. Interesting. I want to make sure none of these pins touch each other. That wouldn't be a good thing. Let's see, what else do I need to do? What else do I need to do? I need to get... yeah, Tesla was the best. Check it out right here. See, way up there? That's Tesla's schematic for, as patent actually, for the first electric motor. So Tesla was better. Edison was an idiot. Edison was just a money hog. Tesla actually wanted to get things done. Let's see. You guys distracted me. We got one from there to there. Pin 3 to pin 2 of this through a 3.3K resistor. Then we got pin 1 going straight to ground. Oh, that's going to be real fun to get. I'm just going to stick a wire in there. Ground is a real pain to get to in these kind of circuits. You also got to make sure that none of the wires touch each other. So we got the bias voltage here. Now we need to find a 10K resistor. Looks right here. Oh, guess what? So all these components right here come from LCSC Components. Go check them out. I'll put a link in the description eventually. LCSC Components sends me free components, and it's awesome, and they're really great. I always use them, and I've never had a single LCSC component break on me. So if you want to get some good components, go to LCSC Components. Best quality components there is. So we got this resistor inside here. That's the 10K right here. Oh, now we got to put this to 4.7K up to positive. See if we can find a good 4.7K resistor. 4.5K. There, 4.7K. That's what I'm talking about. Alright, here we go. Let's bias that one. Oh, I'm running out of pins. Oh, golly. Woo, that's a lot of resistors in there. So we got our little bias resistor up to positive 4.7K. So now we got our 10K resistor going from the collector of this thing to nowhere. So let's get another one. Oh gosh, I'm running out of transistors. What will I do then? Let's put this in here. base. Put 1 to ground. Oh yeah, I've always loved putting pin 1 to ground. Gotta put that every NPN transistor. See, these are my spare resistor leads. The only good thing spare resistor leads are ever good for is this. Watch and learn. Got a negative rail right here. And make that one a negative rail. I kind of want to design a better breadboard. Like maybe a breadboard where I can flip a switch on each rail, and it would either put one to ground or VCC. That would be pretty cool. Alright, maybe this one will work. It's really helpful to have small hands when doing electronics. It's really also helpful to trim your fingernails. I always forget to do that. Too busy. So we got that to ground. We got 10K. Wait a second. Yeah, this is the third transistor. We got that to ground. We got this here. Looks like we need to get a 1K resistor. Here are some good 1Ks. And we gotta put the 1K resistor from the collector, emitter base collector, to VCC. I'll explain how this circuit works later. And then from there, it looks like we've got a pulses pin out. Finally. This pulse pin can go from here to somewhere else. I don't know. Maybe, I don't know. I'll connect it to an Arduino, maybe to another thing. Oh, then we gotta drive the speaker. Gosh, there's so many pins. We need another 10K. Now this circuit I got off the internet says it runs off 3 volts or something. I'm not sure. I may run it off 3 volts. I kind of want to run it off a higher voltage because I don't really want to use 3 volts. We're going to connect that here. This 10K. Connect it to the base of another transistor. Gosh dang it, so many transistors. Okay, just got to make sure none of the leads touch. We're going to connect this transistor to ground to... actually, you're right. Totally analog would be way better. Maybe in a future video, maybe a future live stream, future something, I'll make it better. Let me just check what time it is. 1:26, yeah, I've got plenty of time. Let's just hope I don't eat up all my data. So, if all my data goes away during this live stream and I drop out, that's why. Oh, guys on the live stream, if you want to help me out real quick, go check out, like, the internet and see if I can live stream off a GoPro. Or see if I can live stream off something else other than my phone. See what I can live stream off of. That'd be helpful. Okay, we've got the place for the final transistor. I'm almost out of 4401s. Sticker in there. Ooh, let me guess. Another ground. Perfect. So we got that in, we got that in. Looks like all I gotta do is put a speaker and we'll be done. So let's cruise on over here. I'm running out of speakers too. Tanner Tech headquarters is running out of stuff. This looks like a pretty good speaker. We'll use that for the Geiger counter. Looks like it'll be loud enough to hear the clicks. Yeah, you're right. There's got to be a way to stream GoPro from something. I'll connect this out pin somewhere over here. Scoot all these things back. There we go. Alright, let's pull out some speaker wire. It's this little thing blocking it. Why is there solder on here? That's solder, isn't it? Interesting. Alright, I'll plug that in. Let me wrap up these little cords so I can connect it. Looks like the speaker goes to VCC. So connect it up to VCC. Oh, cool, it fits perfectly. Connect the other one up to the collector of the transistor. Oh, this isn't working as well as I thought. Final last words, huh? There we go. Got the speaker connected. There we go. Now up to, I gotta get it to positive. Whew. We need a black wire. It's always important to have a black wire. It's important because it's cool how back in the day sometime people designed the colors for wires. I'm not sure exactly where that came from. Red's always positive, black's always negative. Imagine if red was negative and black was positive. Well, let me clean off my desk. So I think my circuit's pretty much done. Looks like a big mess, but I got my power supply right here. That's 7 volts. I scoot all these things away. Yeah, I could have put the resistor inside here, but I decided to opt out of that. Alright, guys, wish me luck. Wait, actually, I need to grab something. Interesting. Got some good stuff up here. Let's see if I can find the most important thing. Oh yeah, here we go. Check this out. 3 volts, 1 amp. They should run it. No batteries, perfect power supply. What the heck? Interesting. Okay, most important part. Yeah, so the actual power supply, the 400 volt power supply, needs 7 volts input from my variable bench power supply. And this circuit needs 3 volts according to the schematic. I mean, it will probably work off more, but probably not. I don't know. Let me scoot some of my transistors out of the way and connect it to the variac. Fire this thing up. Let's measure it. Let's see. Confirm that it's running properly. We got my multimeter over here. Let me put it so you guys can see this thing. Oh no, this variable power supply up here isn't cheap. This thing's like $100. That one works really good. This power supply, it could be cheap. I mean, if it's wonky, I don't know. It probably has like an LM317 or something in there. Let's check to see if this works. I'm guessing it's center positive. Hopefully it is. Center positive, 3 volts. Look at that. Works perfect. Yeah, this does have a 60% chance of working. Kirby wood is there. Let's check this out. I need a connector to adapt this thing to another thing. Looking for connectors as we speak. Here we go. There's a good proper connector. Stick it in. Now the real question is, which pin is which pin? I'm guessing this pin is ground. This pin is positive. If we hear some clicks, we'll know something's up. Let me just double check this. I wouldn't want to screw up my whole circuit based on a false assumption. Something's not working. Alright, so it looks like this front pin is positive. I got that part right at least. And the back pin is ground. So we'll connect that up. This is very wonky at the best. Oh, I just heard the speaker click. That's a good sign. Alright. Wish me luck, guys. Hopefully I don't electro boom this thing up. I'm going to connect the high voltage power supply, or maybe low voltage power supply to the high voltage power supply. So the high voltage power supply can be high voltage supply for the Geiger tube. Wish me luck. If this thing goes electro boom, it's not my fault. I heard something click. Oh, there we go. Alright. So this thing is running. I haven't heard a click yet. Now here's the real thing. So I realized that my highest radiation source are these americinium bits. Let's check it out. Ooh. Nothing. Oh, that really sucks. Well, it's not working yet. Interesting. Well, it looks like we're not getting any pulses from this. Okay, I'm careful with that. Let me just check the voltage and make sure that's fine. Yeah, I'll check the power supply. I mean, I'm pretty sure it's working. We're getting 388 on there. We're getting 250 across the resistor. That's not good. That could be an issue. I've got this resistor, which is interesting. That's odd. Okay. Who votes that I bypass this resistor and see how well it works? 1 vote equals 1 dead Geiger counter for Tanner check. And I'm going to get some pliers for this thing. I'll be right back. Alright. Got some pliers. Let's put the americium source right there. Right next to the Geiger tube, so if anything happens, we'll hear it. We should be hearing clicking right now. Let me bypass this resistor. Nothing. Oof. Let me turn off this high voltage power supply. That's working right now. Diagnosis is always an issue. Wait. Let me fire up the high voltage power supply again. And read the voltage across the Geiger tube. Oh, we're getting 240 volts across the Geiger tube. That could be an issue. 240 volts is not nearly enough to run this thing. Okay, let me see if I can find the data sheet for this Geiger tube. Oh, wait. Nope, look at 0.8 megabits per second download speed on my Wi-Fi. Looks like I'm not using this to figure out something. I'm going to search the schematic for this Geiger tube somewhere else. Yeah, I don't need the pop for volume control. It's not really necessary. I think the Geiger tube just has not enough voltage across it. I'm pretty sure this isn't working as well. But luckily, I may have another solution. So, I'm not one to give up easily. So, let me just scoot all these wires out of the way. But a long time ago, I made this thing. Not even sure if it works. Oh, yep, it works. So this is a high voltage power supply for vacuum tubes. Let's see how well this works. It's been a whole load of times since I set this up. This thing should give out the proper things. Alright guys, for those of you who want to see electro boom style. Alright, ready? For those of you who are waiting to see electro boom stuff. Boom. Electro boom. Now, if you look at this power supply, it's been a long time since I made this. It looks like we've got 150 volts when it's on. Looks like my max voltage is going to be 280. Let's see how right that is. I'll flip it to 280 and then to next switch. And I think I have to switch my power supply on high. We'll turn on the isolation transformer. This whole thing is isolated. And then we will measure the value on this capacitor. This should be a lot better of a voltage to run at. Oh yeah. That's what I'm talking about. We're getting 460 volts on the output of this thing unloaded. Whew. Let's set that down maybe a little lower. Let's try it again. Oh. Something's smoking. Guys. Something's smoking inside here. I'm not sure if that's a bad thing. It smells like burnt dust, like when you turn on your heater after 2 years. Let me test it again. Something's obviously not fine, but I'm hoping that we can... 284 volts. Now what's it at? 460 volts. $460. Yeah. It looks like that's working pretty good. Something really smells. Let me smell down here. Well, it doesn't smell up there. Guys, if you don't see it, there's smoke coming off this resistor. That's not a good sign. It smells bad in here. I guess I electro-boomed that thing. Let me just disconnect this, and I'll short out this capacitor. Now, the whole point of this resistor on here was to discharge it so it's safer, but safety is not my #1 priority. So we're going to disconnect these 2 resistors right here. This should give us some better stuff. Alright, now it's time to get some diodes. Find a 100-volt Zener diode. I'm really hoping I still have these things. Oh, I have a Zener diode drawer. Forgot about that. I really hope. Alright, so if someone wants to be helpful, you can look up part number 1N4. Okay, can someone look up 1N4143A? Can someone look up the part number 1N4143A and tell me if that's a 100-volt Zener diode? That would be helpful. Actually, I think I found my 100-volt Zener diodes. Yeah, so these resistors kind of burnt a little bit. Let's get another breadboard for power. I don't think my old Geiger tube power supply is going to work well. Oh gosh, we got a power supply buried over here. Maybe that'll serve us good. We got our 4 Zener diodes to regulate the power to 400 volts. Because right now this thing's running at like 350 or something. So it's cool. Zener diodes can actually regulate power really good. You just got to put a lot of them in series. So each of these Zener diodes is rated for like 100 volts or something. So we'll connect these all together. Right now it's not going to be very portable, but we should get at least 400 volts across the tube. That's the main purpose. Oh, this thing is still on. That is not a good thing. I was messing with high voltage and it was still on. Silly me. So we got our 4 regulatory Zener diodes. Thanks everybody who's watching this right now. And live streaming 1080p video. I wonder how many gigs that takes of my data that's going away right now. Alright. Nope, that's negative right there. That's positive. So we're going to disconnect these wires. This is my lame power supply. We're going to connect it to my cool power supply. We have a high voltage right here. Negative voltage right here. Now we need to connect these 2 points to the 2 points on this burning capacitor. I really hope it's not charged and not on right now, because if it's charged and on, I'm screwed. Honestly. Wait. Oh, I got some notifications. Oh, it looks like my battery is getting low. I've got 19% battery left. We got to get this done before my battery goes. Let me short this out. That capacitor was charged. Some alligator clips. Connect that one to positive. Another alligator clip. Connect this one to negative. Okay, so we got a vacuum tube power supply, this thing, and this thing. Oh, that could have been the cause of our issues. Speaker was never connected. Huh. Well, scoot some of this stuff off. You wouldn't want to ruin that. I'm going to move everything off the Geiger tube. Wouldn't want to short that out. That would be a bad thing for sure. We've got the Geiger tube connected. We've got the americium. I think everything is running. Everything's connected. Disconnected my smoking resistor. Oh. Hey, check it out. Can you guys hear that? Yo, can you guys hear this? It works perfect. Okay. Let me see if I can get this in. Whew. That's just 19% battery left. Okay, can you guys hear these clicks? Alright, so you guys can all hear the Geiger clicks in here, correctly? Correct? Let me just double check the voltage. Still 465 volts. That's fine, though. No, that's not background, actually. I have my americium right there. So, that's background right there. It's just doing a few clicks for a second. Alright, cool. So as you can hear, this thing works perfectly. Now, Eddie Van Horn. Check this out. I got Eddie Van Horn's Trinitite. Slightly higher than background. Still not that many clicks. Here, just a second. I got an idea for all you people watching. I'm going to put an LED on the pulse pin and see if I can get a visual light for you guys to see this better. But I'm excited. I smell something burning right now, but that's fine. Okay, something's really burning. These Zener diodes are heating up a lot. Let me turn off power. Short out the cap. Okay, I'll check the... Woo! Oh, gosh. Yeah, those Zener diodes are hot. I don't think they're meant to be run that hot. Interesting. Yeah, we'll turn it on again. Look at that blast. Cool, that works. Here, Eddie Van Horn, let's try this. Oh yeah, those uranium beads are extremely hot. That's pretty cool. And let's try my yellow cake. Yellow cake. The yellow cake is the hottest of them all, I think. Let's put an LED in there. Now let's check the circuit diagram, because I'm not sure where the pulse pin is. So it looks like the pulse pin should be high normally, and it draws down to 0. Actually, I think the pulse pin, I should put an LED maybe here. Here, I want to hear those clicks. I want to hear some clicks. Okay, so if I put an LED right here going from 3 volts through a resistor, of course, to ground, it should work. Okay, wish me luck. I have 14% battery left. Oh, it looks like something's not working. LED is constantly lit. Interesting. Here, let's try out. So the uranium beads are pretty loud. Let's see what else is loud here. The Trinitite doesn't have that much radiation inside it. The yellow cake is the strongest by far. So let's put that near it. Can you guys all hear this? Comment if you can hear the clicking. Whew, that's a lot of comments. Cool. Well, there you go. You guys came here to see a video about how to make a Geiger counter. Well, guess what I did? I made a video, and I made a Geiger counter. So, cool. And you can even hear all these background clicks. What else do you guys know that's radioactive? I've heard neon light bulbs are radioactive. I'm not sure. Let's check. Not really. Let's see, what else do you guys think is radioactive? So I've already tried all my sources. Actually, let's check all the sources together. Americium. So much radiation. So much. Put the uranium beads there too. Oh, we're getting so much radiation here. Oh, I love this. It's so fun. This is going to be super helpful for the apocalypse. Super helpful. Oh yeah, when I got this oh, it's called carnotite, potassium uranyl vanadale hydrate. And that's the chemical formula, and it's from Moab, Utah. Pretty interesting. Someone said, where am I going to college? I'm going to college MIT, hopefully, Caltech, BYU. I've applied to all those. So, yeah. That's my Geiger counter circuit. I never got the light bulb working. I'll probably get this thing into a really cool enclosure with a better power supply later, sometime in the future. Because I'm probably burning these Zener diodes right now. That's not a good thing. Let me look at the comments. Oh, an old mantle for a camping lamp. Salt, TVs, microwaves. Batteries, bananas. Oh, wow. I missed a lot of these comments. 100K in line with the Zeners. That's a good idea. Tap water. Okay, just a second. I've got 13% battery left, and I'm still on LTE, so I don't have that much time. But let me go find some radioactive sources. Let's go around. Gotta lower my tripod a little bit. Let me turn off my high voltage so I don't burn those Zener diodes for too long. Okay. Oh. The Geiger's still working. Forgot this capacitor is such a big thing. It'll run for a long time. Look at that. Power supply's off. The charge in the capacitor is running this thing. That's cool. That'll be helpful for the future. I can just charge the capacitor once and let it run. What in here do you guys think is radioactive? Oh, a banana. Here. Hold up. I'm going to get a banana. You can listen to this thing click to background radiation all day if you want. I'm going to go find a banana and maybe a camping lantern. Let me turn this on real quick just to charge up the cap. So, here. For now, while I go grab some radioactive stuff, you can listen to that thing clicking away with yellow cake on top of it. I'll be right back. Alright, someone said there's cesium in the lantern wicks. Guess what I have? Giant lantern and banana. Let's get rid of this yellow cake. Let's put a banana on top of it. Let me restart the power supply real quick. Charge up the cap. Ooh, look at that. That's the banana. No clicks. Just background. Well, that sucks for the banana. Here. Let's back it up so I can show you my lantern opening up. Now the real question is how to open this lantern. Oh, there we go. Just gonna pop it open. Oh no, look at that. The lantern's cracked. Oh no, gosh, dang it. The lantern's all cracked. This lantern is bad. Sorry you guys aren't seeing this on live stream, but check it out. Lantern mantles. Someone lied. These things aren't radioactive at all. Here's your so-called radioactive lantern mantle. Look at that. No clicks. That could be because my power supply's off. See, that's background. These lantern mantles don't do anything. If you guys want, just to prove it, this thing may have older lantern mantles in it. Just background. Sorry, guys. Hate to break the bad news, but it doesn't produce that much. At least we got yellow cake. That produces a lot. That's cool. Well, looks like we got a working Geiger counter out of this. Thanks for watching my live stream, guys. Let me look at some of these comments. Oh yeah, pre-1970s mantles. Okay, I'll have to find one of those old ones. An analog clock with hands, I'll find those later. Thorium. Yep, I could make an analog counter. I'll have to figure that out. I am a Boy Scout, actually. I have my eagle. That's pretty cool. Wait a second, I'll find it. Someone was talking about Nuclear Boy Scout. Check it out, Tanner Packham, Eagle Scout. Okay, I will enable Super Chat soon. Yeah, someone was mentioning Nuclear Boy Scout. I am an Eagle Scout, of course. So, yeah, it's cool. Yep, I've read all about the Nuclear Boy Scout. So I guess I am considered a Nuclear Boy Scout. Ha, cool. Well, anyway, that's the Geiger counter. My phone's about to die. The comment thing is really screwing up. My phone's at like 9% battery. So that's why I haven't been able to read comments. I mean, I'm looking at them. My phone really messes up. So I'm looking at all the comments right now. This guy wants to check out his channel. I'll check it out later. Ashes from cigarettes. You know what? My phone's about to die right now. I'll get this Geiger counter working really good, and then I'll go all around my house, and I'll find all kinds of radioactive stuff to measure, including these radioactive things. So, that's pretty cool. Yep, I was on EV blog. Well, let's get some of these things over. As you can see, this power supply is still running. Let's check the voltage real quick. Let's see how much voltage is on it. Oh, it's still at 384 volts. This thing could probably run for a long time on the capacitor. I may make kind of like a crank thing, where I crank it up to charge a big capacitor to like 400 volts or something, and then I just let it run for a while. Because this power supply has been off for like 10 minutes, and it's still at 384 volts. This thing could probably run a long time on a capacitor. That's pretty cool. So, not sure what else to show you guys. I may make another live stream soon. I'll probably be uploading a lot more videos this week. I applied to MIT, Caltech, all these things, but I don't hear back from them until March. And so, yeah, I hope I'll get into one of those. It'd be cool to go into a really cool electrical engineering school. Also, thanks to Eddie Van Horn for sending me those Trinitite and uranium beads. Those were really fun to mess around with in this live stream. That's pretty cool. I may make a video about how to make a way better Geiger counter sometime soon. I'll try to figure out how to make the LED work, maybe put a comparator on it. This Geiger tube works a lot better than my old Geiger tube. That thing was garbage. Well, that's it, I think. As always, thanks for watching, and stay tuned for my next video. And my internet's still not working, so I probably used at least 2 gigs of my data on this live stream. RIP. Yeah. I'll have to find some way to make up that. Maybe buy some extra gigs of data. Well, as always, thanks for watching, and stay tuned for next time.